Hi everybody. Okay, so today we are going to be doing investigation 2.2, and this is building a thermometer. So I'm going to show you guys I'm going to build my own thermometer. We're going to see how this goes. I'm going to warn you guys, this experiment has a habit of not working. And so just bear with me. We're going to get through it as best we can. If anything, we're going to measure what green food coloring if nothing else, we're going to measure how green food coloring reacts with hot water. So, our focus question today is, what happens to water when it gets cold? What happens to it when it gets hot? So, I want you guys to just think about this, alright? I have, in this bottle, green room temperature water. What does room temperature really actually mean? Does anybody know? All right, very good. Room temperature is what the current temperature of the room that you are in is. So we are going to be working to make our own thermometer using a glass bottle. I've got a straw and I've got a little cover. All right, and so this is insanely hard to get in here, but I have put the straw into the top of this, and this is going to eventually go into here. Does that make sense? All right. So what we're going to do is, and we're going to be using an actual thermometer to measure it, but you guys will still see, theoretically, how much the water goes up. So, we're going to put our little cup into here, because I do not want green food coloring on my floor. And we're going to put green food coloring into the bottle. Alright. And we're going to fill it pretty much all the way to the top. There we go. And I will save this for later. Maybe I'll need it again. I don't know. Now I'm going to put this in here. And I'm going to set it in the room temperature. And we're going to... Let's see if I did that right. 1 second. I'm just making sure I did it right because I don't know if I have to fill it more. Okay, I actually need to add more water to this. So I forgot that we're going to need it to go up the... Alright, so we can see it in the pipe. Does everybody see this as it goes up the pipe? Good. Alright, so that's room temperature. And I would agree if I put my thermometer next to it. Now, we are going to... Okay, now we're going to put it in the hot water. We're going to watch, hopefully, the liquid rise. The whole idea behind a thermometer is that as the bulb or the liquid gets higher, that the liquid behind it gets taller. I don't know if it's working. That's quite disappointing. Well, we're going to let it sit for a minute, and we're going to talk. So, while we wait for this to go, the word that we're really talking about is expansion. So, as the water gets warmer, it expands. When the water expands, it takes up more space so that it has greater volume. When the water got hot, there wasn't room for the expanded water in the bottle, so what it should be doing is pushing, and I think it is going up a little bit, is pushing the water. Yeah, it's plenty hot. So it pushes the water, or pushes the green water farther up. It's not quite doing what I wanted, but you guys get the idea. And so, think about different ones that work the same way. What kind of other thermometers have it? Alright, so there's the thermometer. It's the same idea as when we take our temperature. Now, a lot of you guys don't have the thermometers anymore. But for example, the one that I use at home is an old mercury thermometer. All right, it's a lot like this, except there's no metal. There's none of this metal on the side, and you push that under your tongue. And so let's say I have a fever, my temperature would rise, and it would heat up this bulb at the end, and so the red liquid would go farther up, and that would tell me how much of a fever I have. And it does look, we can see here, looks like the liquid's gone up a little bit, so that's a good thing. So now we're going to take it out of here, and we're going to put it back in its room temperature container. See? And we're going to drop an ice cube in it. We're actually going to drop a couple ice cubes in there. And we're going to see if we can make the water go down. Now, the whole idea is that the water will get colder, and so it will contract. When the water contracts, it takes up less space. When the water in the bottle takes less space, the water level goes down the pipe. And I don't think it's going to go down. I may have overfilled it, which would have a lot to do with it. But the whole idea is that as the bulb, or in this case the liquid, heats up, the liquid expands and goes up, all right? There's more of it because it takes up more room. And when it gets cold, oh, there it goes down a little bit. Sorry. When the water contracts, the water gets smaller, or it takes up less space, so it goes back down too. All right, so what I'm going to have you guys do is there is an online activity called, what is it called? If you guys go to the FOSS website, you can go to bottle thermometer, and it's a tutorial, and this will show you exactly how to do this. All right, a little bit more reliably than this experiment. Remember, guys, that I told you this one had a habit of not working. All right, but the two things that you have to take out of this is expansion and contraction. All right, I will see you guys later. Bye.